Hi students, how are you all? I'm back with the seventh part of electricity. If you have missed the first 6 parts, no problem. All the links are there in the description box. You can check that. And in seventh part of electricity, mainly we will discuss about the EMF and potential difference. Potential difference already we discussed. So mainly EMF. And then we'll discuss what is called voltage drop, then internal resistances. All this we'll discuss. Actually, all these terms are related to a cell or a battery, you can say. Okay. So first of all, we'll discuss about EMF. But before starting EMF, I want to tell you the full form of EMF. EMF stands for electromotive force. Understood? Electromotive force. But this is not a force. The meaning of force, that force and this electromotive force, I mean EMF, it's not a force. Though force, the word is there, but it's not a force. It's electromotive force. This is EMF. EMF of a cell. To have the idea of EMF, we will consider a conductor. Simple conductor we'll consider. Say, this is the piece of conductor. Fine. It's a simple piece of wire. Now, what I'm doing, this end, I'm just giving this end all the negative charges. These are all negative charges I'm giving here. Fine. And all the positive charges I'm giving this side. Fine. These are the positive charges here at this end, and this end all the negative charges are there. And as we know, only the electrons, I mean negative charges, flows. Positive charges does not flow. When an electric circuit, when you pass electric current by a cell, only the negative charges flows. I mean electron flows, not the positive charges. Positive charges or protons, they do not flow. Only the electrons flow. So here the electron will flow. Understood? The electron will flow towards this direction. Fine. And all these negative charges will flow here. The negative and positive, they will come together here and this will neutralize. Fine. Now if I ask you how much time it will take for the electrons from here to here, you understood my question? What is the time required, or what is the time the electrons will take to travel from here to here? 1 hour? Half an hour? 1 minute? No, not even 1 second. It's much less than 1 second it will take. Understood? It's a fraction of second. Within fraction of second, all the electrons will come this side and they will neutralize there. Understood? But to keep it continuing, I mean so that electrons keeps going to the positive charges, for that we can make a special arrangement. What is that arrangement? What I'm doing, I will connect this terminal and this terminal with a cell. Okay. Another cell I am connecting it. This is negative terminal, this is positive terminal. Fine. Positive terminal, negative terminal. So see, now this negative portion is connected with the negative side of the cell. This is the cell. Okay. That means the electrons will move now continuously. So we'll get a flow of electron, continuous flow of electron. Understood? Now we will come to the definition of EMF. What is called EMF? See, say I am taking 1 coulomb of charge. Fine. 1 coulomb of charge. If I tell you that the total amount of work done, understood? the total amount of work done to circulate an electron. Understood? From here it will circulate here. Okay? This electron is going and by here it is coming to this positive terminal. How much work is done? That work is called EMF of this cell. Understood? I repeat, the amount of work done, the total amount of work done to carry 1 coulomb of charge. Okay? To carry 1 coulomb of charge. Charge means this negative charge from here to there. What is the amount of work done? That amount of work done is called EMF of this cell. Understood? Now we will see another way to understand the term EMF. Fine. Let's consider that you bought a battery, a simple battery, a dry cell from market. The dry cell which we use in our torchlight or say any music system. Okay, that battery, that simple dry cell. Now this is my dry cell which I bought from the market. Okay, this is plus terminal, this is minus terminal. Fine. Now what I am doing, from here I am connecting a wire. Fine. From negative terminal also I am connecting a wire. Now I want to find the potential difference of this battery. Okay, how to find the potential difference of battery? We know that by using a voltmeter. Voltmeter is a device which gives us the potential difference. So we have to connect it here. Say we are connecting a potential voltmeter which will give us the potential difference. So first what I did, I connected a wire, another wire here, and I have connected with both the wire this voltmeter I connected. Why I connected a voltmeter? To measure its potential difference. We know that voltmeter gives us potential difference. Now you will see that the battery which you bought from the market, you will see that on the body of that battery you will see somewhere it is written 1.5 V. Okay, 1.5 V. That is potential difference of this battery, 1.5 V. And when you connect this battery with this voltmeter, you will also see that the voltmeter is also showing 1.5 V. Fine, 1.5 V. Understood? Now disconnect it. Keep a switch here. This is my switch. Okay, off it and connect an electric bulb with this circuit. So this is my electric bulb, you can see. This is the electric bulb. Fine. Now switch it on. Fine. Before connecting the bulb, switch was off. Now after connecting the bulb, I am switching it on. You will see that suddenly the value showing by this voltmeter will reduce. First it was showing 1.5 volt. Now it will show little less than that. I mean not 1.5 volt, it will show around 1.3 or 1.2. Say now it is showing 1.2 volt. You understood? So what I did, first I bought the battery from the market. Say this is my battery. I am connecting this battery with 2 wires. Okay, with that 2 wires I am connecting the voltmeter to measure its potential difference, and I got 1.5 volt. Yeah, because on the body of that battery it is marked 1.5 volt. Understood? So when you are getting a battery, you see 1.5 V is printed on the body of that battery. That means the potential difference of this battery is 1.5 volt. And when you are connecting with potential difference, I mean voltmeter, it is also showing 1.5 volt. But the problem occurred when you connecting this battery with a bulb. Okay, so when you are connecting this battery with a bulb, then suddenly the potential difference showing by that voltmeter is reduced. Earlier it was showing 1.5, now it is showing 1.2 volt. Understood? So there is a voltage drop. Yes, this we call voltage drop. And before connecting the bulb, it was showing 1.5 volt. This 1.5 volt is the EMF, electromotive force of this cell. Understood? So what is the electromotive force? That is EMF is the 1.5 volt. Fine. And 1.2 volt, we call it terminal voltage. That is V. So V is my terminal voltage. So we'll write it. V is my terminal voltage. Terminal voltage, another name, you already know the another name, that is potential difference. Fine. So potential difference and terminal voltage, they are same. So terminal voltage is 1.2 volt and my EMF is 1.5 volt. Understood? So there is a drop of voltage. We call it voltage drop, small v. We'll denote it by small v. So equal to EMF minus terminal voltage, 1.5 minus 1.2, that is 0.3 volt. This is called terminal voltage. Now one question. Before connecting the battery, it was showing 1.5 volt. But after connecting the bulb, now one question. Before connecting the bulb, it was showing 1.5 volt. But after connecting the bulb, it is showing 1.2 volt. Why? The reason is the internal resistance of the cell. Yes, the battery is made up of something which has got a resistance. That is internal resistance. We call internal resistance. So we'll denote it by small r. So small r is the internal resistance. And this is the reason behind that voltage drop. So what I told you, a battery, when you are trying to connect it with a voltmeter to measure its potential difference, you will see it's showing 1.5 volt. But the same battery, when you are connecting with a bulb, now it is showing 1.2 volt. It will reduce. That is called terminal voltage. And first one is EMF. So there is a drop of voltage. We call it voltage drop and we'll denote it by small v. So small v equal to E minus capital V. That is EMF minus terminal voltage. That is voltage drop. And why there is a voltage drop? The reason is the internal resistance of the cell. Understood? Now let us draw an electric circuit. First of all, this is the cell. Fine. Whose EMF is capital E and small r is the internal resistance of this cell. Now this cell I am connecting with a resistance and which is capital R. Fine. This resistance is the external resistance. The bulb or any electric device, whatever, any electric device, that is the external resistance, and this is the internal resistance of the cell. We will see some equations now. Let's see. As I told you that if I connect a voltmeter here, that voltmeter will give you another value that is called terminal voltage. So here we will get terminal voltage. This is EMF of the cell, this is internal resistance of the cell, and this is the external resistance of the circuit. Say I is the amount of current which is passing through this circuit. Understood? Now I will tell you three equations which you have to remember to solve the numerical based on EMF, electromotive force. Got it? Let's see those equations. First equation. We have to remember I equal to V by R. V is terminal voltage. R is external resistance. Fine. We have to remember I equal to small v by small r. What is small v? Voltage drop. What is smaller? Internal resistance of the cell. Understood? Another equation. I equal to E by capital R plus small r. EMF by external resistance plus internal resistance. So I gave you three equations to find E or R or V or I. Anything you can find by using these three equations, which you have to remember. These equations are very important. Fine. Now let us go for some numericals based on all this formula. Oh, one more equation is there. That equation is, we know that already I told you, voltage drop. What is voltage drop? The voltage drop is small v equal to EMF minus terminal voltage. You remember we discussed that the battery, when no bulb was connected, it was showing 1.5 volt. But when you connected a bulb, it was showing 1.2 volt. So first it was 1.5, now it is 1.2. So there is a reduction, voltage drop. That is called voltage drop, which is equal to EMF minus terminal voltage. So this equation, first equation, and all these three equations. So four equations are there, and you have to remember those four equations to solve the numericals. Now we can start the numerical. Let's start. Hey, can you see this circuit? In this circuit, a cell is connected. See, the EMF of this cell is 12 volt. This is EMF. Fine. EMF is 12 volt. Internal resistance is 1 ohm and two resistances are connected. These are external resistance. What is the internal resistance of the cell? 1 ohm. Understood? A voltmeter is connected and an ammeter is also connected. So we have to find both the reading, ammeter reading and voltmeter reading. What this ammeter will give you? The ammeter will give you the reading of amount of current passing. So let's find it. What is the formula? I equal to E by capital R plus small r. Let us find it. I equal to E by capital R plus small r. So we have to find I. E is 12 by capital R. External resistance. What is the external resistance? This 6 and 6 both are in parallel. So we have to calculate the external resistance first. Let us find that. What is the formula? When the two resistances are connected in parallel, 1 by R equal to, like that, equal to 1 by 6 plus 1 by 6. So equal to 6, 1 plus 1. So R equal to 6 by 2. That is 3 ohm. So 3 ohm is my external resistance. So I will write 3 plus, what is the internal resistance? 1 ohm. It's given in the question. 1. So that is 12 by 4. 12 by 4 means 3 ampere is the amount of current passing through that circuit. So that is 3 ampere. So this reading is 3 ampere. Any doubt? Let us find the reading given by this voltmeter. Can you tell me what is this called? The reading which the voltmeter is showing? Yes, this is called terminal voltage. So what is the formula to find the terminal voltage? I equal to capital V by capital R. I told you the equations already. So what is the equation? I equal to capital V by capital R. Fine. Now I already we got 3 ampere. So use it here. So 3. What is the external resistance? External resistance is 3 ohm. 3. Fine. What is the terminal voltage? We have to find this V. So V equal to 3 3 is a 9. So my terminal voltage is 9 volt My EMF is 12 volt. Now can you answer me? What is the value of voltage drop? How much voltage is dropped here? So voltage drop equal to EMF minus terminal voltage, correct? Terminal voltage. What is EMF? EMF is 12 volt minus what is terminal voltage? It's, where is terminal voltage? 9 volt. 9. So 3 volt. So this is my voltage drop. This is my terminal voltage and this is my amount of current. Understood? Let us go for another numerical. Now see this circuit. It's a very simple circuit where a cell is there with EMF E and internal resistance smaller, and capital L is the external resistance. And in this question we have to find the value of EMF and internal resistances. So first it is given that if the, you can see the question is displaying on your screen, and the first case it is given that when the external resistance is 7 ohm, the current passing is 5 by 4 ampere. Fine. So let us see first what is the external resistance? 7 ohm. So R equal to 7 ohm. What is the current passing? 5 by 4 ampere. 5 by 4 ampere. Fine. So let us develop an equation by using that formula, I equal to E by capital R plus small r. Let us use that. I equal to E by R plus R. I is 5 by 4. So equal to, what is E? We do not know. What is capital R? 7 plus small r. Cross multiply it. 4E equal to 35 plus 5R. Fine. Now equal to 35 plus 5R by 4. Equation 1. Now read the second part of this question. In second part it is given that when the external resistance is 5 ohm. What is the external resistance? 5 ohm. Then the current is 5 by 3 ampere. So current is 5 by 3 ampere. So we will develop another equation by using the same equation. I equal to E by capital R plus small r. Let us put the values. I equal to 5 by 3. What is E? We do not know. What is capital R? 5. 5 plus small r. Cross multiply it. 3E okay, so equal to by 3. So this is my second equation. Now see, in first equation equal to this, in second equation also equal to this. This is also equal to E, this is also equal to E. That means this portion and this portion are equal. Let us equalize them. Now 35 plus 5R by 4 equal to 25 plus 5R. 25 plus 5R by 3. Cross multiply. Now 3 into 35, 105. 4 into 25. Understood? Now 15R, simple calculation. 15R minus 20R, 100 minus 105. So we are getting minus 5R equal to minus 5. Let us write it here since we don't have space here. So what I am writing? Here I am writing. What is that? Minus 5R equal to minus 5. So R equal to 1. So my internal resistance is 1 ohm. So I got internal resistance. Now by using any of this equation, we can find the EMF of this cell. Okay, let us find that. Let us use this equation. What is E? 35 plus 5 into 1 by 4. So 5 1 are 5. 5 plus 35, 40. 40 by 4, that is 10 volt is the EMF. So what is the EMF of this cell? 10 volt. So in this way, by using both the equations, we got the EMF of the cell and the internal resistance of the cell. So I hope the whole concept regarding the EMF and internal resistance of a cell are cleared. You must practice these sums. The whole things will be cleared. Okay. Thank you.